And so the difference here will be that they already tell you kind of what category it is, so you don't have to like uh, guess or figure out, right?
Sure.
So I think having a category hint helps a little bit. But that's obviously something that you won't get
In
uh,
the real interview.
in the right, exactly.
Yeah, that's fine. All right. Welcome back to day 15 of LeetCode Grind. Solve or go home. 30 minutes solve or go home. So today, a slight variation. Skipping the daily. Apparently, it's too hard. So just looking at some other stuff. All right. What are we looking at?
Yeah, you should go to the Explorer page
I'm there. My stream's
yeah.
live, by the way.
Then inside the feature, I think there's the top interview questions.
Yes, I see that one. Okay. I have
Okay.
22% of that done.
Okay. So do you think we should just go through things that you've done before or things that we haven't done before?
Should probably do a new one.
Okay, that's up to
Actually,
you.
I'm pretty sure I did valid Sudoku before. Why is it saying I didn't do it?
Let's do that one. That one is actually pretty good. It's straight up implementation. It's
Yeah, I think I
no.
did it with you before, but I forgot the implementation. So shit, I
Okay.
have to do it again.
Then let's do it. Then
Oh
let's do
no!
it.
Oh no! All right, fine. Do you see it?
Uh, yes.
This is an easy question.
It's easy in that like you don't have to think too much about it, but
No,
you still have to
you
implement.
have to think a lot. Okay, okay. Do you see it?
Yeah.
Okay, okay. So I know the rules of Sudoku, obviously. So it's basically saying determine if a 9x9 is valid. Only the filled cells need to be validated according to the following rules. Okay, you don't care about the rules. We already know the rules. So basically, I just have to check to see if the input is valid, basically, right? Like, can it be solved or something?
Mm-hmm.
So I'm not actually solving it per se. I'm just looking through to make sure it's a valid board. That's it, right? I don't have
Right,
to
right,
solve it.
right. How do
Okay,
you know? How do you know it's valid?
I see. Okay, okay. So basically, there's a couple of conditions. First condition is make sure there's not any duplicates in any row or column,
Mm-hmm.
and in each grid there's no duplicates. So that's those three checks right there. Each 3 by 3 grid has to have no dupes. Each full row has to have no dupes. Each full column has to have no dupes. And obviously in each 3 by 3 grid, no dupes within each row or column. But that would be, I think that check would be like handled by the full row and full column, right?
Mm-hmm.
Okay. So those are the only three checks you have to worry about, I think.
Right, right. So can you make this very modular and you easily call check one and check two and check three and then be done?
Sure, yeah. So yeah, basically have three helper functions, and then
Mm-hmm.
you just call those three, and then return um, a first method and second method and third method, basically.
Right. Sure.
Okay. So the question is, all right. So if I'm doing this, how the logic flow for 3 by 3 square is a lot easier than the full thing, I think, because visualize. Yeah, if you're just literally loop through the whole thing. Okay, wait. First off, you're looping through. You don't need to loop through the whole thing per se. You just need to loop through the row and the column separately, right? So you loop through each row, check there's no dupes, and then you loop through each column, check there's no dupes. Which is technically you are iterating through the whole 2D array, but then it's like you're just looking at specific stuff at a time, right?
Right, right, right. So there's, as you mentioned, there's the three conditions, right? Each
Mm-hmm.
row has to be 0 through 9. Sorry, 1 through 9. With one copy at most.
Mm-hmm.
Um, and then each column, same thing, and each 3 by 3, same thing, right?
Yes,
So
yeah,
you're building three helper functions that check for each of these things,
yeah,
right?
yeah.
So
Okay,
right,
but
right.
so the
So
thing is for the 3 by 3, you're
mhm.
also checking row and column also, but it's within the scope of the 3 by 3. So
No, no,
it's
no, no, no. You don't have to
oh
because
you're just
I
gonna
mean,
loop through the whole 2D array instead.
well, it's a yeah. I mean,
I
there's
mean,
nine
I guess yeah.
boxes.
That's I mean yeah. Wait, that's guaranteed to work, right? As long as Yeah, as long as there's no dupes at all within the 3 by 3, then you fulfilled both conditions, right? That makes sense.
Also that they don't give you like a 0 or 10 or something.
Oh yeah,
Like
sure, sure,
like
yeah. Or
make
or,
sure
or,
it's true.
or basically just check to see, make sure that it's only between 0 and 9, and it's a number, right? I don't think they're gonna
Well,
send you a string though, right?
no, no, they give you
Oh,
the
these are
dot
strings. Wait, they
string.
give you what?
So in the board input,
Hmm.
if it's not filled, they give you a dot. So
Yeah, I'm just saying there's no way the input's gonna send you an A in here, right? They're not gonna do that. Should I check for that? I guess I could check for that. Check is digit basically,
you could, but
but they're probably not gonna do that, right?
uh, I don't know. Look at the inputs, I guess, or look at
I mean, the
all the
inputs
things.
they give you here are clean. They're not doing like -1s. They're not doing 10s. They're not doing zeros. It's just 1 through 9. So, well, that's the example anyway. But I assume they're not gonna do that to you. Obviously, in a real scenario, you probably want to handle those cases. But
Oh, I see. They right. They allow it. I see.
yeah, because
Then
it's
yeah,
a string. You
can
can
ignore.
literally put whatever the hell you want. You can put like A B C D.
Right. Then you can ignore.
Right. Yeah. Okay. So that's fine. All right. So I think doing the 3 by 3 is the easiest first. So you just handle that one. Okay.
No, but you have to do every 3 by 3.
Yeah. So what my thinking was, you're just passing in the 3 by 3 grid into it and just checks it.
Right. But then how do you look through all the 3 by 3s?
You okay. So you define this helper function, right? And then
Hmm.
outside in the main method, you're looping through the the entire section, and you're just passing in each 3 by 3 into this. So you're doing it n times. Was it? It's not n times. It's like well, this is actually no. This Sudoku is hard coded to was it 9 by 9? I think three.
Hmm.
Yeah. So you're basically just doing it 9 times.
Right.
Yeah. So yeah. Yeah. You just literally pass in this first thing, check it's good, and then you pass in this thing, check it's good, pass in this thing, check it's good, and you just do that for all 9 of them. If any of these fail, then you can just return false immediately.
Okay.
Okay, so yes, I think if yeah, so I do define check 3 by 3, and then I just pass in grid, and then I return a bool for let's just define so row equals grid len grid I think. Well, I guess these are hard coded 3 by 3. Just do 3. Do I even need that? Okay, so basically to check dupes, it is so easy way to check dupes is just make a set, right? If you can't
Hmm.
put it if you can't insert, then I mean if you try to insert a dupe, it's just gonna return false, and then you can just return false there, right?
Well, you can. Well, it's not you can't for a set you can add to it if it's already there, but you can check membership by seeing
Oh, yeah, if
if
it's in it, yeah, okay, okay, that's fine. Okay, so set num set equals set if grid row call in num set return false. Oh, why did I do that? Else I else that's why there's no else. It's just return false, and then it just returns true at the end. Yeah, that's fine, I think. Yeah, because then if it's in the set, that means you have a dupe. If it's not in the set, then you're fine. There's no dupes in it. It doesn't care. I think that logic checks.
Right, but look at the inputs.
Oh, because of the dots, right? The dots are
Right.
going to be duped. Okay, yeah, that makes sense. So to check for that, I have to check if it's in numset and it's not a dot. Yeah, we don't care about dots. The dots can be dupes for all I care. And then, oh wait, no. Else, I do have to add. I have to add it to the set. I forgot to add it to the set. Was it? Is it add? No. Is it just this?
Yeah, numset.add.
Oh yeah. Okay. So what? Oh, I'm just adding grid row col. Yeah, that's fine. So in Python, the set, if you try to add a dupe, it just doesn't add it. It's fine, right? It doesn't throw an exception.
No. So I mean, adding a dupe doesn't do anything really.
No, that's what I'm saying. Like when you call add on the dupe, it won't add it, right? It won't care.
Right.
Okay, cool. That's fine. Then I don't have to check for that. And I don't have to care about the dot case. Okay, I think that's fine. Yeah, and then define check row, total row. Okay, so I'm just gonna be passing in an array, a 1D array of each row. So it would just, I guess it would be, no, total, yeah, total row is, yeah, one row each, so I'll just call it row. Okay, also numset equals set for I in range, this is range 9. If row I in numset and row I not equals dot, return false. Else numset dot add row I. Yeah, that should be good. And then return true. And then the total column is really simple too. Actually, this is the same method as row. I can literally use one method for both of these, and just because I'm just passing in either a row or a column. It's just shaped differently.
Okay, so are you gonna process it beforehand, or
What do you mean by process it beforehand?
are you going to collect all of the column zeros or something into an array and then pass it?
Yeah, I was thinking of doing that. Is like you're just like given your 9x9 grid, you can just build out each of these and just pass them into these methods.
Okay, so then you can just have one method that checks that entry, right? And then everything else is just processed into a row.
Everything's processed into a row.
What if you have, so if
Oh, you're saying my 3x3, I just change it into like flatten it into a row and just pass it in. Is that what you're saying?
well, you're gonna do that for a column anyway, then
I mean, I wasn't particularly like transforming it. I was just, so if you think about it, if you're passing in a row here, right? The row is just an array, a 1D array. Isn't a column just a 1D array too? Oh wait, no, it's a
Yeah.
it's a
No.
2D array of one element, of one per row, right?
Exactly.
Oh, that's why. Okay. So I don't know if do I want to transform it? I could transform it, but I could also just
It's up to you. It's up to you.
I could just do it here. All right, I'm gonna do this for now, and I might if it's easier to transform it, I'll just reformat this because then I think it's fine to have this. Okay, so then instead of this, it should be this. Okay, if I'm just gonna do row call for this one. Oh wait, it's not for 3 because it's in range 1, and then this one is in 9. Yeah, it should be this. Okay, that should be fine. Yeah, and then row call. Okay, the problem is I named these two bars the same thing. So I'm just gonna full spell this so it doesn't break. Return false and then return true, else. Okay, that should be good.
Oh, wait, hang on. What is line 31?
What do you mean?
What is range 1?
It just goes to. Wait a minute. Oh no, the column has 9 rows and oops, it's flipped. It should be 9 and 1. Well, I guess you don't even need a 4. Then my bad. It's literally just 0. Row, yeah, should be 0. And then I guess I didn't need this then. Let's switch it back. Okay, that should be fine. I think that's fine. Okay. Now that I have the 3 methods, I just have to call these 3. So when I'm calling these, I loop through the array. So for I just set it up. Row equals when I guess it's 9. Right? Row is 9. So grabbing the 3x3s, you can programmatically build each 3x3 beforehand, right? So you loop through. Alright, how do you build these 3x3s? You can do it. You can do all 3 operations in one full loop, right?
Yeah.
Or can you?
You can, but you have to know where to start and what to process.
Yeah.
Because technically, you just do each of them 9 times, right? So you should, if you have a loop of or in range 9 or something.
Mm-hmm. Okay, so each of these need to be do 9 times. Okay, so how do I access the first row? Let's think about the row visualization first. So the first row is the 0th. Okay, so it's the 0th index
Of board.
of board, yes. And then it's to call it is board 0 0. Wait, so no, it'll be I, right? I 0.
Board I. Board I.
Oh, is it just board I? Each row is board I? Yeah, that makes sense. Oh, the 0, no, board I 0 is the column. Oh, wait, no, it's the columns is board 0i is the columns. Wait, no, no, no. No, 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 no. No, that forces. Wait, no. How come it's so hard to visualize 2D arrays? Okay, so the board 0th index is
First row, the 0th row.
yeah. Okay. So the column would be board 1. Wait, what? How do you? Why is it so hard to visualize the columns?
Column is the row doesn't matter, but then you're taking the 0th element after the row, or the first element after the row. So it's board row 0, board row 1, board row 2.
Yeah. So when you say row, it's just literally 0.
No. If the column is 0, then you want board 1, board 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 0.
So, yeah. So for column, the 0th index is board 0i.
No, it's board row I.
But we don't have row.
Oh, but you have board, so it doesn't matter. You can just pass board in. Or sorry, you can pass I as the column, right?
Yeah, I is the column. Yeah, sure. But what is the row in this scenario? We don't have a second loop for this.
It doesn't matter. You can say you will look through the 9 inside of
Wait,
your
is it I?
no, and it's diagonal. But for every row, you check the ith column.
Not sure. I know what that is.
So what's column 0? It's 0, 0, 1, 0, 2, 0, 3, 0.
Yeah.
Right?
Yeah.
So you have to go through every row in the board, and then you have to take the ith element of that row.
Ith element of that row.
So in fact, what you should do in line 31, it should be for row and board. And then do row of column.
So instead of passing column, we're passing the board?
Well, I mean, you can pass the board, or it's already inside this method, so it's fine. You can call it.
Whoa.
The column is the index. Column is the index. You need to iterate through the board to get the row, and then you can index the column of that row.
Nope, I'm not getting this. Alright, I'm gonna grab this. So these are the rows. The columns is downward, these things. So
No, the rows are downwards.
no, these are the rows.
I don't know where you're having.
Left to right is rows. Top to down is columns.
Correct.
Yeah, that's what I'm talking about. So for the columns, yeah, this is 0, 0, 0, 1, no, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0.
Right.
And this
Right.
one is 1, 1, 2, 1, 3, 1, 4, 4, 1, 5, 1, 6, 1, 7, 8, 8, 1.
Exactly.
So it's always
row.
each
Row in
column,
the board.
the second index is I,
Mm,
but then
no,
the
no, no.
first.
For each row, the second index is what you want.
Wait, what?
So what's row 0? Oh, sorry, what's yeah, what's the 0th row of this matrix?
It's the first row.
Sure. And what's the, 5th column of that row?
Fifth column is 4, index 4, so it's 0, 4.
Right. So you want the whole column of index 4s. It's gonna be 0, 4, 1, 4, 2, 4, 3, 4, like that, right?
Yeah.
But you can just go for each row in the matrix. You just get the column's element of that row.
For each row in the matrix, get the column element of each row. That makes no sense.
Like, okay, you have an array and you want to find the certain index of that array.
Yeah.
Okay. Now you have an array of arrays.
Yeah.
You want to find an index of every single array in that array.
An index of every single array in that array. I guess. I don't know. Sure.
Um,
Isn't
Okay,
it,
so what
isn't it
happens-
fine to just double loop it?
Why are you double looping it?
So right here is for I in range 9. So you can just pass in all the rows because you're looping through 9 of them, right? But while you're doing that, you can also have another row var that loops to 9 also, so that way you can grab all the columns.
But you can't from each. What? Okay, maybe I don't quite see what you're doing, but
Because then if each column is literally just the row and then I.
all
And
the
then-
rows. It's all the rows.
Yeah, so like if you start with the first column, it's 0, 1, right? 0i. And then the second one is 1i. And the third one is 2i, etc., right?
No. No, the first column is all of these. It's not the first and second and third. It's every single one of them.
First column. Yeah.
It's row.
Yeah.
row
So yeah, you want all of them. But yeah, so wait. Yeah, but then like, so the first column 0i, the I is indicating the downward trend of in your I in range 9, right? So you're gonna loop through for I in range 9 anyway. You're just gonna do all of this. So it'll be like 0, 0, 0, and then 0, 1, 0, 2, etc., right? Until you hit the 8, 0, 8.
So then you just did a row. Like what?
Oh wait, that is a row. So so if that's the row, then the column is the flipped one. Yeah, it should be flipped. Okay, I see. So it's not. It should be I, and then row. Because then it would be. So I in the first thing is 0, 0, 0, and then 0, 1, 0, 2.
What? You're doing the same thing again.
Oh, that is the same thing. Wait, what? No. Oh, okay. Oh, oops. I flipped in and I still didn't fix it. Okay, it should be, yeah. It should be 1, 0, 2, 0.
Yeah, I think
etc. to
Okay, you
80.
have variable confusion. You should not use row. You should use index or something.
Yeah,
Because
I'm not calling it row. I'm calling it something else. But I'm saying this. That's why. So this for I in range 9 is the I part. But then you need a second var that also loops to 9, which handles this part.
no, but that should be inside of the checked total column. Thing.
What do you mean? Oh, wait. For row in range 9, if column...
Right. No, it should be board of row of column. That's it.
Oh, so this one we specifically use the board instead of passing in the whole one at a time. We're just passing the whole board. We're just using the whole board.
There, you don't have to like anything weird with it. You just have to find the right index. Board of row of I. Well, a board of row of column will get you the.
So, alright, so if I'm passing column, column is I and row is
Row always goes through 1 through 9. Right?
yeah 0 to 9. Okay, so if that's the case, if I'm passing in, like let's say in this scenario, I'm passing I is 0, it's gonna go as 1. It's gonna go 0 0 0 1 0 2.
1 0.
No, this is. Oh wait, no, this row increment. Yeah, it's gonna be 1 0 0 1. Okay, yeah. 1 0 2 0 3 0 4 0 5 0. Yeah, okay, that's fine. And then yeah, because column. Okay, yeah, the column will loop through 9, and then the row will loop through 9 each time. Okay, that's fine. Okay, I see. Okay, so row equal row. Okay, so help check total row I. No, it wouldn't be I. It would be board I.
What? What? Oh, I see. Okay.
Board I is each row, right?
Yes.
So I need a boolean for this. Wait. If, yeah, I'll just do an if check. If board. Wait, actually, no, we should store it so we don't have to call it again. That's bad. I guess I don't have to optimize it too much because the n, when you pass an n, it's static. It's 9 out of 9, which is super fast anyway. There's no added runtime at all. So I don't have to do this. That's fine.
So what happens if the check total row is false?
Yeah, that's what I'm saying. I didn't want to list out all these cases, just return false all the time. But it's fine, I guess. Okay. Because this looks like really stupid code. Did you literally, if it's not total row, then you return false. And then else you check the rest of this stuff. Okay,
I
so
mean, they don't have to be dependent on each other. You can just call them all, and then if any of them are false, you should
yeah,
return false.
that's why. Yeah, that's what I'm saying. So I don't technically have to do this to optimize it, because then this basically allows you to exit at any time. If you do all three, you have to run through the whole thing.
Yeah, what else?
Yeah, that's why I said this code looks really dumb. You just might as well just do all three and just return all three at the same time. So you're just doing um, see, this is fine, but it doesn't allow you to exit. It just checks all of it. But I guess it doesn't cost that much computational power. It's always 9 by 9.
Well, is this right? First of all,
Should be right. Well, this one's not completed yet, but yeah, it's just you just AND all three. Because then if any of those are false, then it's just gonna be false.
but then there should be if not valid, return false.
Why do so you're doing that because you want to exit early?
Well, at the end, your valid is gonna be the last row only, right? Like it doesn't do anything.
No, it does. Because valid. Oh,
Oh,
because I didn't do valid and that's why. But yeah, you can just do that too.
oh, I see. Um,
It just looks weird. And like, who codes if it's not valid return false? This really weird code, but whatever. Does syntax even work in Python? Do you have to do this?
yeah, here's not.
Okay, that's fine. Alright, so I just have to figure out the logic for the 3x3s. The 3x3 is... okay, so for each 3x3, it's gonna be... The grid is... let's grab this code and isolate it down. How do I grab this without... that's annoying. Okay, so kill this stuff. Okay, so it's the 0th row to the first three of those, and then the second row, and the third row. You pull 3 columns from each. So if I'm looping 9 times, how do I build this each time? 0 to 3, 0 to 2, 1 to 2, 2 to 2, and then the next set is 0. Wait, no, it would be 2 to 4, I think. Plus 2 on this one. Wait, no. Wait. Oh, you know, that's right. 2 to 4, and then this one is. Wait, no, it shouldn't be 2 to 4. It should be 3 to 5, and then 6 to 8.
Okay.
And then this one is 4. Wait, what? No, it's not 4. Wait. One to 2 doesn't make sense either. It just means it's the first row, but you still start at 0. So it's 1. And this one's 0. 0 rows, and these are the index. So you need 3 per 0. Yeah, that should be fine. Yeah, so these are all the same. It's always 0 to this. Okay. So for each row, so I guess that's the in range 9. I need to build a 2 by 2 array of the 0 to 2, and then the 3 to 5, and then the 6 to 8. Wait, no, that's wrong. This is shit. No, each, oh my god, each 3 by 3 is 0 row. Why is this so confusing? Zeroth row goes to 3. First row also goes to 3. Second row goes to 3. And that's your first 3 by 3. Okay. The second one. Okay, so this pattern is, if I'm looping through 9, it looks like, okay, how do I get this one and this one?
Also, you have you're looping through 3 and 3, so you just have to give it the start coordinates and then have an offset or something, right?
Wait, what? Okay.
You start at 0, 0, you know you have to go 0, 0, 1, 0, 2.
Yeah.
1, 0. You start at 0, 3, then you know it's 0, 3, 0, 4, 0, 5, because your starting coordinate is 0, 0, 0, 3, sorry.
Sure. Yeah, you need, you need 3 in each direction, but then
no, you already have the loop in your check thing, right? It goes from range 3 and range 3. Why don't you just give it a starting location?
No, because I'm trying to pass in a grid, right? A 3 by 3 grid.
Yeah, but you can also pass in a no. We can also just pass it a start location or something.
Yeah, then I have to
Board
modify.
is
I would have to modify this method.
a little bit.
Okay, yeah, because I was under the assumption that I was keeping this, but I guess I can modify it.
Yeah, I mean, if it makes sense, keep it. If it doesn't make sense, change it.
Well, it makes sense. It's just hard to build this array, and I didn't think it would be that difficult. So if I do it like a starting location, I would be passing in the coordinates to start. I would be passing x and y, row and column, and then I would just be looping it 3 in both directions.
Right.
So instead of parsing in a grid, I'll be passing in row and column, and then for range 3, I would be using in. Okay, so let's just call this with different bars. Just x, y, whatever. So then it'll be in range x. No, because the starting one is x. So for x, how do you force the row to start at x? Do you just do x
Oh,
in
you
range?
the what?
No, that doesn't work.
No. We're oh, this is the offset, dude.
What is the offset?
It's x plus row and y plus column.
Um, that doesn't work because this is range 3.
That's fine.
Wait, how does
So it's
that?
gonna be 0, 0. So it's gonna be x, y, then x plus 1, y, then x plus 2, y. Right?
Wait. So you're saying if I do for row plus x in range 3, and if row,
No.
yeah, that's,
For row in range 2,
yeah,
and for a column in range 3,
uh huh.
then you do if board of x plus row.
Because we're using the board now. That's why. Okay, so it would be row plus x and column plus y. Okay, so if I'm offset, so if I'm passing in the starting location is 0, 0, so x and y is just plus 0, it doesn't change anything. But if the offset, the new offset is the second one, I would be passing in 0. I think the 0. Wait, where did it go? 0, 3. So 3 is the next offset. So it starts column at 3. So that's fine, right? So it'll start from 3. Yeah, 3 plus. Oh, 0 plus 3 is 3. So it'll start at 3, and then it'll do all the checks from 3 to 5. Okay, that's fine. Yeah, that looks fine. So that means I will be passing in x and y. X and y. So each starting location. So if that's the case, I can't use. Yeah, so I would have to have a var to handle the starting shifts, the offsets. So
Or you just create the array of that.
what do you mean?
Because so And your for I in range 9 thing at line 60 or something. You can just say starting locations equals and then that's that array. Okay.
Starting locations. Oh, okay. So you're saying. No, you're the only var changing is y. So y equals
No.
0, 3, and 5, because x is determined by I. So you're just passing in I and y.
No. That's not right.
Why is that wrong?
You're starting with
Oh
range
no,
9.
we can't do I because we have to shift downward too.
Right.
Yeah, never mind. Then for this shit, what do we do then? We need.
You can explicitly write it, then you don't have to worry about it.
Yeah, but it's gonna loop. We have to build it outside the loop, so we don't want it to loop multiple times. We don't want this array to be built multiple times.
Sure, that's fine.
It's 2, 0.
No. Always plus 3, right?
Yeah, it is plus 3, but it doesn't look like, because when. Why does it go from 3 to 5 then? 3 plus 3 is not 5. I think it's.
Because 5 is 6 minus 1. Your 0 index.
Yeah, this is also 0 index though. This. Isn't it?
Right? It is.
Yeah, so it should be 2, 0. Not 3, 0.
No, it's not 2.
Wait, why is it not?
Because 2 was in the previous grid.
Is it?
Every grid goes for your. What?
Oh, yeah, 2 is part of the previous grid. Sorry. Yeah, you're right. Wait. That doesn't make sense.
It makes perfect sense.
It doesn't make sense to me right now. I don't know. I'm missing something here. Why is...
Each thing is the 3 by 3, so you should be upping by 3 each time.
Yeah, but then you're not in the... When you go 0, 0 to 0, 3, that's fine. But 0, 3 to 0, 5 doesn't make any sense.
No. 0, 3 to 0, 6.
Yes. Wait. 6. Oh, it is 6. It's not 5. See, that's why. Okay. I confused myself. Okay, that's fine. And then 6, 0, 6, 3, and 6, 6. So given all this, we want. So we just pass in these. We just loop when we're looping through. We just loop through starting locations and just pass these in too. So for I in range, then we just pass in starting blocks I. That will give me the tuple, right? Does the tuple map to this?
I don't know if that's valid. You might have to do starting blocks I0, starting blocks I1. I don't actually know.
Well, I can just pass in the tuple here, right? Can I?
Well, let's find out. I don't actually know.
No, I mean like, can I just change this to take a tuple var instead of x comma y?
Oh yeah, sure.
So how do you like define that? Is it just parentheses?
You can say coordinate or something, and then say x comma y equals coordinate.
Oh yeah, right here, right. X, Y equals coordinate. You mean like that?
Yeah, I think
Okay.
that's fine.
And then this, when I grab it from the starting blocks, it should just have a tuple, and then it should pass it here properly. Okay, just remove all this stuff. It is not defined. What do you mean? It's right here. Oh, I spelled. It looks like that was true. Is this one false?
You need to get rid of spaces. It'll give you weird input.
Wait, oh, so I can't like do that.
You have to delete the end, the space at the end of each thing. Yeah, it's stupid.
Oh. I don't think there's spaces here, are there? Let me try it. I guess there are still spaces here. Okay, I have no idea if it has spaces or not. How do
No,
you?
you need commas. You need the commas.
Yeah,
You can't get rid of-
I didn't get rid of the commas, did I? Oh, I did. Wait. Okay, that means there should be no spaces then. Okay, that's fine. I think we're good then.
Okay. So, I mean, you solved it. But I guess my question to you is, what if they make an extension where they say like, oh, let's implement check like mega Sudoku, and then they give you like a 25 by 25, and then you have to do this for, you know,
Sure. So
or
yeah, so this is hard coded because I know it's 9 by 9, but I can easily change these hard codes to use dynamic based on the length and the row of the board.
mhm.
Yeah, so like it would be like row equals len board, col equals len board 0, and then just use those.
Okay, so that will help you solve two of the methods, but the 3 by 3 thing is still going to be really annoying, right?
Oh, right. Yeah, you're right. Well, I guess. Yeah. Well, wait. So to part, if it's like, if given like you're saying like 25 by 25, right? Given that, you would. Well, wait. Does that if it's a 25 by 25, does that mean each mini grid is a 5 by 5? Wait, how? What would be the size of each mini grid in the 25
It would
by
be
25?
7.
It would be 5 by 5. Okay. So
Yeah.
basically, the size of the mini grid is the square root of the
I mean, it's just length of row, and then you square root that, right?
yeah.
But
So then
yeah,
instead of this hard coded 3, it would be based on the square root of whatever of that, and that should still handle it, right?
okay, then how do you programmatically generate the starting locations?
Oh yeah, so that is so that one was difficult. That's why it was hard coded. But to do that, I think if you're basically I think it's this for I in len. Wait, no, not len. What is it? I in the length of grid, the length of mini, whatever, and then for j in len mini 0. Well, I guess it's definitely the same size, but basically you're just appending to the array mini I j plus the length. Shit. Wait, I don't. No, so it's for I in len mini. Yeah, so you would want to do it 5 times, or in that case it would be five. There'll be 5 and 5.
Mm-hmm.
So it would be. Okay, so you're looping through. Yeah, so the pattern here is you start with the first row, 0, 0, 0, 3, 0, 6. So if in this case of 5, you're doing 0, 5, 0, 10, 0, 15. And then
yes.
and then the next one would be 5, 0, 5, 10, 5, 15.
Sure.
So in that, it looks like it is just for I in the square root of the 25, which is the size of the grid.
Mm-hmm.
You want to loop through that. So yeah, for I in length of this whatever the square root is, and then for each of those, we loop through that again. So it's a double loop of this, and then each of these we start at 0 index, and then we add the length to each of the y coordinates, and then append it in, and then the next one increments the x coordinate to +5, and then you do the same thing starting with 0 again. So yeah, it's just it's a double for loop then, basically.
Yes. I guess you can think of it also as it's 5 times I for x, and then 5 times I for y, or I guess whatever it is, 3 times I, 3 times x in this case.
3 times I, 3 times x.
3 I. If I is going from 0, 1, 2, 3, sorry, 0, 1, and 2, and the first coordinate is 3 times I.
The first coordinate is 0, 0, right? So you're saying 3 times I is, you're saying I is 0?
Yeah, sure.
Okay, yeah.
The first it's 0.
Okay. Yeah, 3 times I. Yeah, three times I. Oh, I see. So no, you're multiplying by n, right? Not 3. 3 is just
Yeah,
for this scenario. Okay.
yeah.
Yeah. Okay, that makes sense. Yeah. So when you loop through the 5 times, and you do 5 times y, whatever. So you get 0, 0, and then 0, 1 times 5 is 5. 0, 1 times 2 is 10. 0, 1 times 3 is 15. And 0, 1 times 4 is 20. So that gets you the full first thing.
Yeah, that's pretty much it. Okay, very good. Very, I guess, disorganized.
Yeah.
How long did that take, the initial rounds?
1 hour?
Oh, you've been streaming. That's a good question.
Yeah, 1 hour I've been streaming.
Yeah. So this should ideally be done in like 30 minutes.
Yep. Yeah. Yeah, I guess I'm still really bad at 2D arrays. Can't visualize it properly.
Not super algorithmically challenging. It's just coding, straight up coding, right?
Mm-hmm.
But, and you did the modularization, and it's all like separated and such. Somehow you got hung up on like indexing rows, or sorry, columns, a little bit.
Yeah, I'm still really bad at visualizing the 2Ds.
So you can think of a matrix as a bunch of rows that have column number of elements.
Bunch of rows of column number of elements. Sure.
Each row has column number of elements. So So basically, it's just a bunch of arrays of
Yeah,
you know,
it's an array of arrays,
right.
literally. Yeah, I know that. It's just if I'm trying to like access a certain part of the array, it gets
Mhm.
confusing. I know how to instantly loop traverse the whole 2D because that's so simple. But if I'm looking for a specific part of it, it just trips me up.
Okay. Yeah, yeah. I mean, that's fine. Should we move on to a different one?
Yeah,
You can
sure.
pick a different category as well. Like you don't have to go back to arrays and stuff.
Okay, what do you want to do?
What would you like to do?
I don't know.
Choose your own adventure.
Um, I guess I'm bad at dynamic. Maybe dynamic. Or actually, we haven't
Dynamic.
done a sorting in a while. Maybe do a sorting. There's only two questions though. It's just sorted array.
That's fine. Let's do the one you didn't do.
All right. Given two sorted nums1 and num2, merge two into as one sorted array. Okay, that's fine. You may assume that nums has size n plus n such as enough space to hold it. Okay.
Mhm.
So no, this isn't this super simple. If you just sort it, you're just checking. You have pointers in both arrays. You're looping through both, and then you check. You're pointing at the current element in both. If whichever's less, you just add it to that one, to the output, the new output.
Uh,
Unless
I
when
mean,
it says
there's.
merged, you have to do it in place. You can't make a new array.
I think it wants you to make. I think it wants you to update nums one.
I see. Okay, that's fine. I can just yeah. So the issue of that is that even possible? Because so let's say you want to put this two in here, right? So that means the two replaces the three, and then the three you have to push down. So you have to push everything down, and that just takes a lot of runtime.
But that's fine. The size is not a huge problem. They're maximum 200.
No, but like, is that even the correct way? So like, if I'm putting in two, do I have to push everything down?
Right. You do. And then the last guy disappears.
So I'm literally looping through all of these and just changing the values downward. Yeah, is that true or no?
Uh, sure. Yeah.
Oh wow. Okay, I thought that was really suboptimal. I didn't know if that was correct. Okay, sure. Isn't there like a insert into array, or is that like against the thing? This question.
I think they don't want you to change the size of it.
Oh, oh, I see. So that's what it means. Like when you push it down, it just the last element just gets deleted.
Right.
But if that gets deleted, what if you need that last element?
It's always a zero, I think.
Oh, it's saying that the last zeros aren't actually part of the array.
You just allocated
They're
space.
just allocated space, so you could. Oh, I see. Okay, that's fine. Okay, sure. All right. So is it always claiming that nums1 is the one that you wanted in?
Right.
Okay. So in that case, we're looping through nums2, and we have a pointer into nums1.
Mm-hmm.
Okay, for I in nums2. All right, and then current this is a pointer. Pointer equals 0. I'll just call it index, whatever. All right, if I is less than nums1 index, then I have to swap it in and have to push everything down. Holy crap, that's annoying. All right. Um,
You can do a dot insert. Right.
what do you mean a dot insert?
You can insert at that index.
Yeah, but you just said we can't do that.
No, well you can, but you have to
Oh, I have to
probably.
insert and just remove the last one and just pop the last one.
Right.
Oh,
That will be,
is that against the question though? Do they care? That if I'm doing that, I should probably make it a DQ then, right? Wait, actually, no. DQ doesn't save any time because we're not always inserting left or right. It's somewhere in the middle, right? Yeah. All right. So we'll just do it. Nums2, nums1 dot. Is it insert? Is that the syntax?
yeah.
Insert. And you just pass an index and the val, or is it val and index? Which order?
I think it's index first.
Okay. And then I just pass in I. And then nums one dot pop. Else I increment index. And then I don't increment the nums 2. So in that case, I don't want a for I. I want a while loop. Okay, let's just call it nums1 pointer, nums2 pointer. Okay, and then this one replaces index. And this one should increment nums2 pointer. And this one won't be I anymore. And this one's also not I. It should be nums2. I think that's fine.
Mm-hmm.
Oh no. What's up? Index out of range. Did I miss an edge case somewhere? Let's print it out.
You also have to make sure nums1 pointer is less than length of nums1.
Yes. But also it looks like it didn't do any insertion at all.
Oh, it did.
I'm not.
It added the and then it looped itself out.
Wait,
Oh, I see.
no,
Yeah.
it messed up somewhere. For
5
sure.
is bigger than 0. 5 is bigger than 0. That's how they get you.
Does that matter? Oh, it's.
It's no longer increasing after that point.
Wait. So my logic is if nums2 is less than nums1, then I insert it. So nums2 is 5. 5 is not less than 0. That's why it doesn't insert it.
Right, so then it moves itself off the cliff.
So it should be or nums1 is 0.
Well, then you run into a case where you have, let's say everything is 0 in nums1.
Oh yeah, then it's not in order. Wait, no, that is in order because num2 is already sorted.
No, but let's say nums1 was supposed to be an array of 3 zeros, and then it had 3 zeros for padding. You won't be able to tell where the padding is.
Oh, if it's 0 to start, then it's legit. If it's 0 at the end, it's not legit.
Right.
Oh, I
Correct.
see. So, okay, that won't work. Then you have to check.
Yeah, I mean, uh, okay, you know how many nums2s there are, right?
Yeah.
But then you can just get rid of the zeros at the end. I don't know if that's the correct way, but you can definitely.
I mean, you can get rid of the zeros, but you're not slotting in 5 or 6, though.
No, you will be afterwards.
What do you mean? Oh, wait. Oh, wait, what? Oh, you're saying from the start, just pop all these out, and then just insert them normally.
No, so if you pop all of them out, you'll get the array of 1, 2, 2, 3. Then you have 5 and 6 on the nums2 side, right?
Yeah.
But you have to. But then you know that you can't. You know that your number is bigger than everything in one. So you can just stitch them together at that point. So 1,
Oh,
2, 3, 4.
just add the arrays together. So
Right,
when you're done here, you just get rid of the remaining zeros and just append the arrays. But then I would have to pop in this array too. Then
I think you have to start with popping the zeros because you don't know how many to pop.
no, so that's what I'm saying. So I think at the start, you just literally get rid of every zeros. So peak, if it's 0, pop it from the back.
No. You know exactly how many to pop because that's length 2.
Oh yeah, the length of nums2 is the numbers having. Okay, so we just pop them all out pre start, and then we just insert these in normally, and we don't have to pop them out later anymore because it's already popped. I see. Okay. Okay. So all right. So for I in nums2 range len nums2 nums1 dot pop. So I can remove this, and then yeah. So if I popped all of them, this should insert properly then.
Okay. But you also have to check that you're not accessing a nums1 thing. But yeah, exactly. You're gonna access the 4th number of index 1.
4th number of index 1. How did that happen though?
Because 5 is bigger than anything in 1.
Yeah.
So you're like, okay, is it bigger than index 0? Yep. Is it bigger than index 1? Yep. Is it bigger than index 2?
Oh, it's
Yep.
bigger than anything, so it exited this loop and it did nothing.
And you didn't check that your nums1 pointer is less than length of nums1.
Oh.
Oh, in your while, how come you only checked nums2 pointer?
Yeah, because I thought we didn't care about that. Wait.
No, you do.
Nums2 pointer is less than nums2. Yeah, that's because we exit. Okay, I see. So that checks out of bounds on the nums2, but we need to check out of bounds on nums1 also. But then
Right.
that doesn't fix the issue. It's not going to insert 5 at all.
No, that's fine.
Oh, because we're appending it. We're appending it.
So there's 2 cases, right? Either you ran out of nums1 or you ran out of nums2.
Yeah.
And in either case, you have to figure out how to stitch them.
Well, this should be and.
No, not or. And.
Yeah. Okay, in this case, I would have to pop it to nums2 dot pop left. It should be pop left, but we don't have that because we have to dequeue it. Because if we want to append the arrays, I guess I can append it with
Oh,
starting at the
I see.
index that nums2 pointer is pointing at. That's fine. I don't have to pop it then. Then I just do return nums1 plus nums2 nums2 pointer. That.
Well, that's one possibility. You also could have run out of nums1.
What do you mean by run out of nums1?
Like, what if, you know, all of nums2 is smaller than nums1, 0.
Oh,
So
if
you
they're
had
all
4, 5,
zeros. Okay.
and you run out of nums2.
Wait, no, you don't. Like, so you're saying if nums2 is all zeros, and nums1 is 1, 2, 2, 3, let's say, right? Or 1, 2, 3, whatever. Then it would insert all the zeros to start, and then your rest of the array is just 1, 2, 2. And then
Okay.
nums2 pointer would be at the end. So if you're appending this, there's nothing to append. It just appends an empty array.
Yeah, you're right.
So I think that's fine.
Okay.
Except it's not fine. Okay, what's wrong with this?
Oh, I think they're looking only at nums1. You have to
Oh,
set
oh, I
nums.
have to set it. I have to set it. Yeah. That's why return doesn't matter because they don't care. They're just looking at it. What is what are you even looking for return then? Is it a void? Oh, it's a no. You don't return anything. They don't care.
Exactly.
Oh, that's why. Except it still didn't work. Shit, I should have just printed it anyway.
Oh, maybe you can't set. Maybe you have to pop and insert and whatever.
You don't think this reassigning works?
I think they make you pop and add. And,
Alright, let me see if nums2 is proper first. Okay, that didn't work.
Looks fine.
Why is it not defined? What are you talking about? It's literally up here. Oh. Yeah, so it looks like the array is working properly. Okay, so you're saying that this it doesn't work because how does this not work? If you're forcing it to be reassigned and you're only looking at nums1, then how would this not work?
Was, but they obviously want you to just add numbers to nums1.
Well, yeah, I know they want that, but if I'm modifying nums1, shouldn't this work?
You should.
So how did they put a failsafe so that this doesn't work? What are they doing? Whatever. All right, so I can't do this method. I have to actually insert it, right?
Right.
So I can't do
You
this.
want to DQ nums2.
So okay, so if I'm doing that, and I go back to the previous logic where there were zeros left, how do I handle that? How do I know if a zero is? How do I know if the zero is a filler?
No. This is still fine. You just want to set nums2 equals DQ of nums2, uh, and then basically for each number that's left over, you just append.
Wait, why do I need to DQ it then? You're literally saying
left.
for I in nums2, nums1 dot append I. Isn't that what you're just saying?
Oh, yeah. Actually, so you want to do for I in range of nums2 pointer and then length of nums2.
Oh yeah. Nums2 pointer. No, this should be
Yeah,
I.
that's the beginning of the range.
Oh, you mean like comma this, right?
No, that comma length of num2.
Yeah, like that, right?
Yeah, that probably works actually.
Well, let's see if they don't let that happen. Oh, they do let that happen. Okay, cool. Let's try this thing. That was M. Oh, you have four things. Wow. One empty array and 0. Oh, M and N is just the length of the arrays, I guess. Why is those inputs? Those don't matter. No one cares about those. Alright, that looks fine.
Okay, nice.
Is this like a solution that is traditional, or it seems like we're cheesing it?
This seems reasonable to me. You can't tell otherwise, right?
Sure. Alright. Alright, do another one, or
Up to you.
you got time?
Feels fast. Yeah, I have time.
Alright, let's check out. Um. Oh, I don't like math. I don't want to do math. I guess I could do a tree real quick. These should be pretty simple, right?
Mhm.
Maximum def. I did a def earlier, so I probably shouldn't do another one. Maybe this sorted array into binary tree.
Yeah, sure.
Okay, all right. So, given an integer array nums, where the elements are sorting in ascending order, convert into a height balanced binary tree. Height balance is a tree, blah blah. All right, I know what a height balanced is. Put explanation. Yeah, so basically they don't really care how you build it as long as it's a proper tree and the height isn't messed up. So I think typically I would do left to right because that's cleaner and simpler.
Okay.
All right, so you're given this nums. It's already sorted. So when it's sorted, that means that in a tree, typically in a tree, you want the um, shit. It's not the left. It's not the left. The least element that's on the bottom. Wait, no. The least element should be the most left node on the lowest level for sure.
Hmm. Okay. So read the problem again.
Integer array nums is ascending order converted to a height balanced binary search tree. A height balance is a tree in which the depth of the two subtrees of every node never differs more than 1. Okay.
Okay. So what does that mean?
That means of the two subtrees of every. Okay, yeah. So that means there's never like an additional like height.
No,
So there can't be, you can't have like 9 5 3 because then you would want the 3, you would want two children before you want another children on the other children. You don't want an empty children on this side before you get.
right. So that means let's say you were to. Yeah. In fact, you're right. So this actually just means that you have as full of a binary tree as possible.
Yeah, you don't want like X. I don't think that really matters. I mean, that's the definition, right? But if you're building the tree, it's probably going to be built correctly anyway. I don't think that this really
So
affects.
let's say you have an array of like 1 through 8, right?
Yeah,
Or like 1 through 7 or something, right?
sure.
So that's the sort of thing. How would it look like in a binary tree?
So I think typically if it's 1 through 7, you would want probably 4, and then you want 5 on the right, and then maybe 3 to the left. Actually, no, that might be bad because, yeah, because then you can't fit the rest of it. So you want 7, and then you want like 3, I guess. Wait, no, 3 does that? Yeah, no, you want 2, and then this one would be 1, and you can put 3 here, and this one would be. Actually, no, you can't. You don't want 7 because that's too big. You want like maybe 5 or 6. And then this one could be 5. Yeah, I think that would be a tree that works.
Right. Now what happens if you have 8 elements?
Okay. You had 8, then you put 8 here, and then the 7 just pops down here.
Okay. Now we scroll up.
To where?
I want to make the problem statement. I just want to make sure this is right. At every node. Okay. I should know the best way to do this.
Yeah, I don't know
So-
either. My thinking was like you want the middle of the array for the head or for the root, and then
Yeah, that sounds reasonable, actually.
you just grab like, oh, I think you're always taking the middle of what's left. So the middle is
yeah.
the root, and then the middle of this is the next child. The middle of this is the next child.
Yeah, that's the correct logic. But I was just wondering if, like, why is it 4 and not 5, for example? So,
Oh, I see. I think well, if you do integer half, it's gonna pick 4 first, right? So this is 8 elements. 8 divided by 2 is 4, so it's gonna pick the 4th index. 1, 2, 3, 4. Oh, it's gonna put 5. I think 5 still works though, right? If you do 5, it should work. If you do 5 and then the half of the 4 to 3, it's gonna put it's gonna put 3 to your left, and then half of this side is 7, and then yeah, and then clearly this goes 6 and 8 for this one, so those are the last ones left. And then on the 3 side, yeah, it's just half of, wait, no, yeah, it's 4. Oh, you still have the 4 left. How does the logic handle putting the 4 then? I think it's 2 and then 1. But then, like, yeah, so if you're doing halves, how do you handle this thing left? Oh, I think it should be half of what's left. So I guess you're constantly popping out of the array, right? So in this case, when you popped out the 5, right, just yeah, you popped out 5 to put in as a head, and then now you separate these into another 2 halves, right? And then you pop out this thing,
right, so it's a
and then you pop out, I think it was 3. Wait, what were you saying?
you don't have to pop anything. You just call the same method on the left half and the right half and assign it to the left and right.
Yeah, the problem with that is, so yeah, let's say you put 5 in first, right? So the left of 5 is 1, 2, 3, 4, and the right of 5 is 6, 7, 8, right? So that's on the right is easy. That's fine, because then you put
3 divided by 2 is 1.
yeah, no. So each oh, okay, so it constantly has a new left and right for both sides, because so I guess that's like the recursion part of it, right? But then like for this side, right, 1, 2, 3, 4, so if you, it would pick 3, right, because 3 is the middle. But then there's oh wow, 4 is the right of 3, so you still have access to, oh okay, I think I see what you mean. Okay, so you want to build a recursive method where you pass in the left and right side all the time, and then you just pick one of those, put it in as the next child, and then on that you make another left and right side on that child, and you pass that in until it finishes. Right?
Yeah, I think that you just have to code it.
Yeah, the coding is the hard part. Okay. So alright, so how do they want the tree built? Oh, you have to init the tree, and then we're just adding tree nodes, I guess.
Yeah.
So, do I need a helper? I might not need a helper for this. Maybe I just do a helper. Okay, so I'm passing in the left and right trees, the left and right side of the arrays. And I need to pass in the current node that I want to add to. So, cur node. I think this is messed up, so I'm gonna refresh real quick. Okay. So I have these 3. And then, okay, if left cur node dot left equals new tree node. Oh, not new. There's no new tree node. Left len left divided by 2. If right cur node dot right is tree node right len right divided by 2, and then you pass in and then you do cur node, you do helper on what's remaining of, okay, it would be, so the cur node would be dot left dot right, and then I also have to check if cur node before I do anything. And then I'm passing in for left side of the tree will be what is it? Am I passing in? Wait, what am I passing in? Okay, so I'm using the current middle element for this. So it's whatever's left from the left side of that element and the right side of that element. But the problem is, how do I access that?
Well, index is length of left over 2.
Yeah. But then, so okay, so it would be oh, okay, so I still have the current left array, so I'm just passing it back in from 0 to len left divided by 2, right? And then plus, or not plus, it'll be left len left divided by 2. Is this plus 1?
Mm-hmm.
And then this one would be the same thing, but the right. Wait, why did it cut off my array? Okay. Does that logic look like it's proper? I think that's fine. Because 0 to left means you take everything from the 0th index all the way up to that element, right? Up to the middle element. Is this what that's doing right here? Hello?
Yeah.
Okay. And then this one is everything after that element.
Well, you're using left again.
Yeah, you're supposed to, right?
Not for the second line.
Say that again. Not what?
Not for line 19.
No. Oh, you mean this thing? Oops. Okay. That should be fine then. And then, so to call this, I need to initiate a new tree node. Tree equals tree node. Oh, and I need to initialize the first tree node, right? Do I do that outside? Tree node. Fine, I'll do it outside. Tree node. So I need to check if nums tree node, and then I pass in. I believe it's val, or just the val. So it would be nums len nums divided by 2, and none, and none, and then just call helper on tree. Wait, no, I need to call tree dot left. Wait, no, that's wrong. That's the arrays. That's not the tree. Okay, it'll be tree, and it would be nums 0 to len nums divided by 2, and this one would be nums 0, or not 0, len nums divided by 2 plus 1. Right though. And then return tree. Is that what they want? Yeah, I think that's fine. And then else, what happens if there's no nums? Then we just return. What'd you say?
There's always nums.
Oh, there's always nums. Alright. Then we don't even need to check it. Okay, that looks like it works.
All right, nice.
Nice. Oh wow, I'm surprised this wasn't that hard.
Good. That means your recursion fundamentals seem to be good as long as you understand what you're doing.
Yeah. I mean, yeah. This helper logic isn't that difficult. It's just figuring out how the tree is supposed to be built. But once you figure out it's just happening each time, then it's pretty simple.
Just happening.
Yeah, the happening. All right. You still got time?
Next.
Or? Okay.
Yeah.
All right.
We got time.
Should I do a dynamic programming one?
Let's do it.
Oh god. All right. Climb. Oh, I already did climbing stairs. So I guess we do stocks. I think this one I never solved, or maybe house robber. I think you mentioned house robber, right?
However, it's a fun one.
Which is it better than stock?
We can do both. But let's start with house.
All right. I don't think you know what fun means, Ellen.
That's fun.
All right. You're a professional robber planning to rob houses. This is unethical. You shouldn't be robbing houses. You shouldn't be building an algorithm to rob houses. That's pretty bad. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Okay. Oh, so basically the only condition is you can't hit houses that are next to each other.
Mm.
Given the integer nums representing the amount of money in each house, return the maximum amount you can rob tonight without learning police. Oh, I see. Okay, yeah, the question is simple. It's just coding it's probably really hard. Okay, so yeah, so given this 1, 2, 3, 1, the best one is you hit the 3 first, and then you just hit the 1 here. Because if you hit 2 here, you can only get the 1 that's 3. Yeah, so, alright. So, yeah, I understand, like, the logic flow. I just don't know how I would handle this.
I see. So I think for DP program or DP problems, generally what you want to do is see kind of like what happens if you choose that action at this time, or you choose not to take that action at this time. At each step, you can, let's say you're at position 0, right?
Mm-hmm, yeah.
You have a choice. You can rob it or you cannot rob
Yes. Yeah.
it, right? And if you rob it at position 0 or position anything, right? Then you now have that position's money plus any money you've gotten 2 positions ago, because you couldn't rob it again if you were from 1 position ago.
So you're saying alright, so you're in the array, you check to see if you should rob it, and then you're also checking to see what you did in the previous turn?
No, I think you have to define the recurrence relationship, right? So at each step, and it doesn't matter where you are, right? You can have 2 options, right? One is you don't rob at your current time step.
Mm-hmm.
That means you just have the. So how much money do you have at that point?
How much
Those are
money do I have? Oh, how much
at
money I
that point.
currently have, yeah. At which position are you talking about?
Let's say um, guess how do I phrase this? Uh, so you have your money at time step t is equal to a function of time step t minus 1 and a function of time step t minus 2.
Why is it specifically 2 times of previously?
Because your cooldown for robbing is 1, right? So
Sure.
if you robbed in time step t minus 1,
Yeah.
then you cannot rob this time.
Well, no, you can rob. You just can't rob next to it.
No, if you robbed in time step t minus 1 and you're currently at time t, you cannot rob.
Oh, when you're saying T minus, are you talking about the the indexing of the array?
Yeah, sure.
Oh, okay. Okay. I thought you meant you're literally tracking the positions. I mean, like, at what time you did what. So when you're saying T minus 1, you're just saying the previous house.
Yes. If you robbed the previous house, you
Hmm.
cannot rob this house.
Yeah, yeah, that makes sense. Okay.
But if you robbed 2 houses ago, you can rob this house.
Yes, yes. I understand that.
Right?
Okay, sure.
And basically, at each house, you have to decide, will I just not rob it? In which case, I have how how much money would I have, and then or do I rob it, and then how much money do I have?
Hmm. Okay, sure.
Right.
Yeah.
So let's say you're at house 1, right?
Yeah.
For example 1, let's say,
Mm,
right?
yeah.
And then I guess at this point there's nothing before you.
Hmm. Yeah, yeah.
So you your maximum you can gain at this point is to
$1.
rob this place.
Yeah, $1. Yep.
Right. So now you go to house 2, right?
Yeah.
So what's your maximum here?
Your maximum here is either $1 previously or not robbing the previous one and taking the $2 here.
Right, exactly. That's exactly what you said is exactly correct. So it's going to be don't rob, in which case you have the previous number of money,
Yeah.
or rob, in which case you have two ago.
You have to give away
plus-
the dollar that you took earlier.
Okay.
You gotta put it back. Yeah.
Right, and then when you go to 3, what is your I guess
Your maximum it's you either take the t minus 2 and yourself, or you take what t minus 1.
exactly. So that's it. So you just have to initialize the array and then just build it left to right.
Wait, so question here though. So basically when you're looking at your current position, you can either take t minus 1 or you can take current one and t minus 2. But can you also take? But then because you have a memo array that stores the constant max of each index, you don't have to go all the way back in time. You just have to look at t minus 2 and current.
That's right. So you assume that you made the optimal decision at the previous step.
I
So-
see. Okay. So yeah, because you're always checking the optimal decision, you just have to add t minus 2 to your current one, and that's your maximum now. So you compare that maximum with t minus 1, and whichever one's better, you store that as your current maximum.
Exactly. That's the whole thing.
Oh, okay. That's pretty simple actually.
That kind of thinking allows you to do a lot of these DP problems.
Yeah, if you're doing like the array solution, right?
And a lot of them are very efficient. You can do most of them in like O of n.
Yeah, because you just loop them through once, literally.
Exactly.
Okay. So I'm gonna have a memo, and I'm gonna allocate it. Do I need to initialize this?
You should set it to. You should probably put like a 0 value or something.
Yeah,
because,
0 times. Yeah, because then we're doing max, so you want zeros, right? So times len nums.
I see. Well, that's optional actually. You can just append and just take the last 2 elements. You technically only need to initialize it with 2 zeros.
Why is that?
Because at the first time step, you have to consider the current minus 1 and the current minus 2.
Yeah.
So then it should be.
Oh, I see what you mean. Okay. Oh, so you're saying 0 0 because the previous 2 time steps don't exist, so that means the maximum is 0.
Correct.
Okay, I see. Okay, and then when you're looping through for I in nums, you are just looking at the 2 previous time steps to see
Exactly.
the current max. Okay, I see. Okay, so if so the conditional is if memo I minus 2 plus I is greater than memo I minus 1. Actually, no, you don't even need to do it if. You just literally just store the max between the maxes. So you just do memo dot append the maximum between this and I. Wait, no, not I. Memo minus 1. Memo I minus 1. So yeah, the 2 choices are take the current one plus it to the I minus 2. Wait, why do I have a greater than here? This is not right. Okay, yeah, so it's a max between the memo of I minus 2 and the current one, or memo I minus 1. And then that's your new max for this current iteration. And then you're just returning memo -1. Wait, is it -1 for the?
Yeah, that's the last step.
Oh, that's the last time step, right? Yeah. So you should have the maximum you can get at that time. So yeah, I think that's good.
Line 6 is weird. Wrong.
What'd you say?
Line 6.
It's wrong. Okay. for I. Oh, oops. Did I mess up anything else? What was it complaining here? Oh, it's just a syntax error. Why does it not like this? What is wrong with this?
You can
Memo.
close the right.
Did I not close it? Oh, there's a double. Yes. Okay. Oh. Zuckerbergs didn't sign up. Alright. That means I have more time to do LeetCode.
Do it.
Oh, there's an event in the game, but my guild leader forgot to sign up, so I don't have to do it. Yeah, I was gonna be like, I need a break, but it's fine. I don't need a break anymore.
They need a break.
Oh no. Okay, so I messed up something here. Index out of range. Why is it out of range? I minus, yeah, we initialized 0, 0, so there shouldn't be any.
You should be using -1 and -2. Don't use I.
What do you mean? You mean like this?
So I is a number. It's not an index.
Oh. Yes. Yeah, so I have to do
No, you don't.
I don't.
Already what the hell?
Wait.
No.
Wait. What you saying? What you saying?
So Python allows you to access the last element with -1 and the second last element with -2.
Oh, okay. Oh, because this array is constantly being appended to, you're always guaranteed the last position two. Oh, I see. That's why. That makes sense.
I think your naming convention for I and nums stuff is pretty bad because it's impossible to tell what I is when you don't look at line 6, I guess.
I see. Yeah. I mean, I think that's like because that's what they teach you in school is just always do the I for loops, but then in like actual software development, I definitely don't name it I. I actually like put a real name for it so it's readable. But then I'm just
for Python, you're actually taking the element. You're not taking the index.
Yeah, I know. Yeah, I sometimes confuse myself for that. Yeah. So yeah, you can't plus I here. This one should be. Wait, no, it is plus I because this where you're at. No, that one's correct. That one's correct. Yeah, never mind. Yes, okay, this is fine then. Alright, yeah, looks good. Submissions. Oh, nice. Wait some. Alright, next one, or you want to discuss some stuffs?
Up to you.
No, like, do you have anything to add?
Oh, style, I guess. I would not name it for I and nums. I would say for num and nums or something.
Okay, yeah, I agree with you. So, alright, that's fine.
Like, I leave I for indices. If it was I in range nums, then yeah, I would do that.
I see. Yeah, okay, fine. I'll just rename it now. Make a mental note of that. GG's. Now I'm lowering my acceptance right now. Alright, that's fine, whatever. Alright, so we doing the stock now?
Well, up to you. That's fine.
Oh, did you have another one in mind?
Not really.
Okay.
You can choose one adventure. It's fine.
Alright, so given an array of prices where I is the given day, you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return maximum profit you achieve from this transaction. If you cannot achieve any profit, return 0. So if you buy on day 2, price is 1, and you sell on day 5, price equals 6, profit is 6 minus 1 equals 5. Okay, note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Okay, that makes sense. yeah, like again, it's a simple question, hard to code. Okay, you just gotta figure out what you want to memorize, basically.
Mm.
So the profit margins, basically, you want, so at each index, you kind of want to store the maximum that you have on that current day. And then if you know that, you can determine if you want to buy that current day's stock. That doesn't help. Yeah, I'm not sure for this one.
Okay, so typically, what would be the most you can gain? Why is in example two you get nothing?
Oh, wait. Is the question say you can only buy one stock?
Exactly. Why is
Oh,
it?
I thought you could. I thought you can buy any number of stocks. Oh, never mind. So maybe that makes it easier. Okay, so you're saying why is this 0? Is that what you're saying? Is that what you're asking? It's
Why is
because
it
this
zero?
array is in descending order. So you anything you buy, you're selling low. Then that's just Wall Street bets. Buy high, sell low. It's really bad.
Right. So
So basically, if the array is in somewhat of an ascending, then you can have a profit. If it's purely descending, you will have zero profit.
mhm.
Okay, but that doesn't help me solve this question though. Unless we're just looking for the minimum value in the array and then looking for the maximum be after that. But then I don't think that case covers everything. Does that? Is that greedy? Does that work? If you're guaranteeing you buying this the minimum, no, that doesn't work because let's say one was like last, then you get no profit. So yeah, you can't. That method doesn't work. So you have to do something else.
Right.
The question. Oh, I think I know what to do. So basically, you're for each index, you buy it. You just like quote unquote buy it, and then you just see the maximum it gains. The maximum gains that current one has at each day, but then you also compare that to the max of instead of buying the previous one, you buying today's one instead. And each day you loop, you check all the previous max profits, and then you comparing that to this max profit, and then you see which one is the better one, and then you store that back. Kind of. I don't know if that works.
Mm. Uh, uh,
Does that work? I don't think that works. Are you like waiting for me to figure it out? Or are you just thinking of what to say?
I'm trying to process what you're saying.
Okay.
Okay, can you say again?
Yeah. So what I was thinking of is basically on each day you quote unquote buy it, and then you check the next day to see if you made a profit, and then and then that value is the max profit for that day currently. But then and you move to and then you buy in quotes this day, and you move to the next index, and then you check to see if this one sells for better than the one that you bought previously, and then that one, or like the max. So like in this scenario, 7-1, right? So you quote unquote buy 7, and then on day 2, you see the max profit if you sold 7 on day 2, you get nothing. So that the max is 0 for this one, and then
Mm-hmm.
you move over to day 3, and then you quote unquote bought this one. So you check the profit here. That's $4. So the maximum on day 3 is $4, and then you move over to day 4, and then you check quote unquote if you bought 5, how much profit you could have gotten, and then you check. So then you do 5 minus 3 is negative 2. So then you don't want that. You zero profit on this day. So currently, up to this date, the maximum you made so far is $4. And then you look at this one, and then you see if you bought 3, how much you could have made. You would have made $3. So then the maximum on this day is $3. Oh wait, yeah, that doesn't take into account the $1 you could have bought. And so
Alright, so I think you want to keep track of the smallest you've seen so far.
Okay.
Right. In which case, on day 4, you would potentially have made $2. Right.
Day
3 minus 1.
Yeah, sure.
On day 5, you potentially would have made $5.
$5, yeah. Okay, sure.
Okay, then I think that works.
But that's not dynamic, right? That's just greedy.
No, it's dynamic.
How's that dynamic? Oh, because you're building the memo array.
Yes. Of what the profits are at each point, and then.
Okay, so you're storing the memo, and you're also storing the minimum value, right?
Right. Memo is the minimum value, and then you can have an output, and then it's gonna be like, if it's greater than the max, then you update it. Otherwise, you don't.
Okay, wait. Let me try to wrap this around my head again. So you're saying the memo is the minimum value. So if I'm looping through this and building it out, I check 7. 7. Well, the first day you can't have profit on the first day, so you don't even care about that. That's just 0. On the second day, it's still 0 because you can't. If you bought at 7, you sell for 1. That's 0. That's bad. And then
in this case,
yeah,
potentially
there's profit, and then you would store that as the maximum profit for that day, right?
No, but you don't need it for that day. You just need global maximum profit.
Oh, okay. Then
what
are we specifically storing in the memo then?
The smallest thing you've seen so far.
Oh, so at each index we're just storing the smallest possible stock price?
In fact, I don't even know if you need memo.
Yeah, that's what I'm saying. Is it just greedy? It seems like it's just greedy. Because if you're just storing the minimum,
that might be fine. Actually, yeah. I think in this case, it might not even need to.
So wait. So you're just storing the minimum price. No, you're storing you're storing the maximum gains, but then how do you know that? How do you know what stock will give you that?
It doesn't matter. Like, if you bought a minimum earlier, and then you're currently at this location where you exceed the maximum, it means that is the current best thing you can gain at that time.
Yeah, but how do you know which stock you're selling on the current day you're at when you're iterating?
If you wanted to, you can store the index, but it doesn't matter. You don't care. You're selling one stock.
Yeah, but how do you know which one you're selling?
The minimum one.
But it can't. The minimum doesn't always work, right?
Why doesn't it work? In which case does it not work?
What if? Oh wait. Does the minimum always work? What if it's? Oh, it's the minimum you've seen so far. It's not the absolute minimum of the array.
Right.
Oh, okay. That's why it works. Oh, okay. Wait, isn't that super simple? How's this dynamic programming?
I don't think it is actually.
Okay, so min equals min stock price equals I guess we'll just do what was that? It was like float infinite or something.
Oh, yeah, float in.
Okay, and then for I in prices, for price in prices, prints for prints in prices. Prints is $15, by the way, if you remember. But yeah, if price less than min stock price. Oh, actually, you don't even need an if. You just set it. Min stock price equals min of min stock price and price, and then you calculate the the maximum profit you could have gotten with that. So you do max profit equals 0. Max profit equals max of max profit and price minus min stock price. And you just return max profit. Right?
Mm-hmm.
Why so simple?
Because if you think about the problem, then you can get it.
Then why call it DPs? Oh yeah, this looks like it works.
This doesn't require DP. The well, you sell more than one, I think you will require DP.
Oh, that's yeah. It's probably the best time to buy and sell two, right? I think I remember that question. So that one's should we do that one or not?
It's up to you.
I don't know. Maybe should we try something else?
Or I mean, you can also ingrain this and then think about it and then come back to it next time.
What do you mean by ingrain this?
I mean, this is supposed to be learning for you, right? You've done 4 so far, like
Yeah.
Or more than 4 actually, right? 1, 2,
5 maybe. I did 1 array. I did 1 tree, 2 DP, and 1 sorting. Yeah, so it's 5.
Okay. Maybe do 1 more.
All right. Should I do design or what?
Sure, design is good.
Which one? Shuffle or a min stack? Do you know these questions?
Maybe. We could do min stack.
All right, fine.
Design is generally approachable, I would say.
Well, design is just what I do at work. It's not really LeetCode. Design a stack that supports. Oh, it's just designing a stack. Supports push, pop, and top, and retrieving the min element in constant time. Okay. So it's a stack that pushes and pops and retrieves the min. So is that saying when it says retrieve min? Oh wait, no, never mind. It defines it here. Removes the element at the top. Okay, so it's just a regular stack, but you have a get min also.
Mm.
But then does that mean in that scenario that when you pop from it, you're not when you're popping, it's just like a regular stack, right? Like, so it just pops whatever's on the current top of the stack. It doesn't care about ordering. The only method that cares about ordering is the min method, right? So
right.
We don't want to order this stack per se. It's just we just need an extra method that handles the minimum.
Mm-hmm.
Okay, so in that case, so yeah, if it's just a standard stack and we need a min, we just we probably want to just track the min, and that's it, right? We just need an extra variable to hold the min, and then we just return that.
Right, and then when you pop them in, you should also recalculate min.
Yeah, recalculate min. Yes. So in order to recalculate min, would I have to loop through it each time? Okay, instead of that, what if I have a separate data structure, like a heap? In Python, Python's a min heap, so if I just literally use that to track the min, then I can just pull from that each time. And then I'll be constantly always sorted by the min, right?
But the problem is when you pop from the stack normally, how will you update the bin heap?
Oh, right, that's true. Because then if I pop like in the middle of this, yeah, because that element might not be anywhere near the min. Yeah, you won't know how to access it. Wait. But then in the min heap, does it have method to pull out whatever you want, or does it literally only do pops? Can you delete an element, a specific element?
By the index, you have to.
Oh, so if I store the index, then it should be fine.
I'm not sure about that.
Oh, okay.
Don't quote me on that.
All right. So if that's not a valid, if that's not a valid use case, then what else can I use to I guess I could literally, if I'm just tracking the min, I can just re-loop through the stack and just find the min again. Oh, wait, what is there? Oh shit, 2 to 31 power. What is that?
Well, that's each number.
Oh, that's just a number. But how many? At most 3 to 10 to the 4. That's a lot of numbers. 10 to the 4 is what, 1,000.
Yeah, but
So
I
it's
think
3,000 elements. What were we saying now?
Min is not that. It doesn't take that long to calculate. I think it's probably log or something.
No, it's because if it's 3 to the 10 to the 4th power, that means maximum 3,000 elements. No, that's 30,000 elements, right?
Yeah, it's pretty fast.
30,000, like if you just kept looping through all of it, shouldn't cost much runtime, right? It should be fine. All right, then I just have a recalculate min method, right? Then self.min equals integer volts infinite. And then what else? Oh, we need the stack. Self.stack equals array. Actually, if this is a stack, no, that's fine. All right, recalc min is for I in self.stack for num. If no, just self.min equals min self.min num, and then for get min just return self.min. Is that a bad sound or is that a good sound?
Well, I'm just concerned if they call min like every time, then you're kind of screwed, right?
Oh, I see. Like if they're calling get min a lot, I have to recalculate a lot.
Yeah.
Okay. I mean, if that's the case, then we might as well use the heap and then try to figure out how to delete from the heap. What else would work for that then? If it's min. Oh wait, what if? No, that doesn't work.
What if you keep track of the minimum at each time?
What do you mean by at each time? Oh, at each point of the stack. Stack. So like a tuple. The stack has a tuple, like the element and the min at that time.
Right. So something like if you have 1, 2, 3, if you're inserting 1, 2, 3, right?
Yeah.
Your min when you insert 1 is 1.
Yeah.
Your min when you insert 2 is also 1.
Yes.
And your min when you insert 3 is also 1.
Yes.
Okay. Then when you pop 3, you're like, oh, I'm just gonna pop or sorry, the 1 hasn't changed.
Yeah.
So
but what if you what if you popped 1?
No, but you know at that time it's still 1, right? Okay, so let's say your insert is 3 to 1. Right?
Yeah. Okay.
So the min at the time you insert 3 is 3.
Yes.
And your min when you insert 2 is 2.
Mm-hmm.
And min when you insert 1 is 1.
Yeah.
Then when you pop 1, then you still have the 2, 2.
Yeah. I mean that's fine, but what about the opposite direction? Does that work? So
I think you just need something that keeps track of what you added and the minimum at the time you added it.
So like in this scenario, right? So you would pop the 3, right? No, does this pop 1 or does this pop? This pops 1. No, this is a stack. It's gonna pop 3 first. That means you're left with 2 and the min is still 1. Yeah, that's fine. So this case works. This case you pop 1. Yeah, both cases work. When you pop this, you still have min at that time. So this should work fine, right?
Right.
Okay, yeah. So we don't need this. And then get min is just literally peek at the stack and pull them in. Wait, no, we can't
Oh,
do that.
yeah.
No, we still need to store them in. We still need to store them in. I mean, we still need to return the min. Wait, no. Okay, so in the stack we have the min at the current time. Oh, okay. So when we pop it, we just reset min. But then, so here we can still return self.min here, because we're at every time we'll know the min. Yeah, we'll know the current min for that value at any time, at any given time. Wait, so wouldn't it just be the top of the stack min?
The top of the stack is not min, but top of the stack comma min could be a tuple that you store.
Yeah, that's what I'm saying. So
Yeah.
you would do self.stack 0 1 no -1 1, right? That should be the min at any given time. In this case it was 3 1, so if you peek at 3, yeah, 3 is 1, 1 is 1, yeah. And then if you pop these, the min when you peek it's 1 and 2. That's correct. Yeah, so this should work. Self.stack the last element's first index, which is the min that you're tracking. Yes.
Right.
Okay, that's fine. Alright, so what do they want for pop and top? Is it just typical stuff? Removes? Okay, that's fine. Gets the top element. Top is just the top of the stack, right? So literally just a peek. Return self.stack -1 0. And then when this is when I know this is a pop, but can we literally just call pop 2, or do we have to actually remove it? Okay. Because it's weird. It's like, oh, they're calling pop, but I'm calling pop on my pop. Yeah. Alright, whatever. So to pop this, I would just call self.stack.pop. Literally. That's it. That's mad simple. It's just the push is the hardest code, and it's not even that hard. Okay. So it's self.stack.append tuple of val and self.min. Oh wait, pop I have to reallocate min. So I need to do, wait, no I don't. No, it's already set. Never mind. Yeah, I'm good. Yeah, and then this is fine. Self.min. Yeah, any given time self.min is this. Wait, but when do I update self.min?
And push.
Right. But I'm putting self.min. So I have to set it first. So oh wait, that's a bit confusing. Oh, wait. So when I push, I'm passing in the current min. Oh yeah, no, that's fine. I'm just passing in the current min. But then when does it? Oh, it doesn't need to update.
Oh, it does. Otherwise, it's always going to be infinity.
Right. Oh, right. Self.min goes min of self.min and val. Yeah, that should be it. Self's not defined. Why is self not defined?
Not necessarily right.
Which part? The push part? This thing?
No. The line 15.
Yeah, that's what I'm talking about.
That means the moment, let's say you pushed a bunch and then you popped one, right? Self.min hasn't changed.
Yeah, it has not changed.
So I think it really depends on, like, you should check if, okay, so what happens at the beginning when you have nothing in your stack?
So you have nothing in your stack. Self.min is the min of this current val. So this current val that you're pushing in, let's say in this scenario is 3. So it's gonna set min to 3, and I'm gonna push
Right. So there
3
should not be
and 3 to the stack.
there should not be a self.min value
Why not?
because you don't want it to be outside of the stack.
Oh, you don't want it to be global.
You want it to be relative to the stack. There's no elements, then obviously the value that you have is the smallest you've ever seen.
I see. Okay. So wait, but then how do what is it? Is the min just val then? It can't be.
Well, it depends if stack.
Oh wait. I think I know what you said. So min of get min and val.
Well, first of all, you cannot get min if stack is empty.
True. So if stack else min equals a float infinite. No, min equals val. Yes. Yeah, that's fine, right?
Then you need to call self.getMin.
Oh, sure.
I don't know if I would use the same variable twice.
Oh, for the name, yeah. What the hell do I call this? Also, this is wrong. Just call it stackmin. Yes. Self is not defined. Who's using self? Wait, what is it talking about? Self, that's stack. Alphaz, why are you complaining at me?
You're init, dude. You're init. Has to have it.
Oh, you just do stack?
Oh, you need
Oh, it's not inside the init. Oops. Nice. Good stuff. It's always good stuff here. Okay, cool. Cool beans. No beans. Stack is not defined. Did I call stack? Oh, yes, I did. Why did I do that? Where else do I call stack? I don't call it anywhere else. Okay. Oh, that looks correct. Oh, they don't have any other inputs, so I'm just gonna assume it works. That's how you program. You just assume it works. Nice, and it does work.
Alright. Guess I'll give you a little break after now. Feel free to take the contest if you want.
Oh no. Do I want to?
It's up to you.
Yeah, we'll see. Maybe.
That bag of random shit.
I might actually no. Contest's at 10:30, right?
Yeah.
Yeah, probably not. My friends might want to play. I'll just join them.
Alright.
Alright, cool. Thanks, man.